Why does a white web under leaves make so many people recoil? Why does the sight of it, a pale fuzz threading through mulch, stitching dead leaves together, the underside of a flower pot or a damp corner of the garden bed, trigger the same old alarm in so many human minds? Rot, infection, contamination. Get rid of it, and yet, most of the time, what you are looking at is not the beginning of a disaster. It is the visible edge of one of the oldest systems of renewal on Earth. A living architecture made of fungal hyphae, threads so fine they can be about 1/60th the diameter of a typical plant root hair, quietly moving through the dark and doing work without which ordinary soil would stop being ordinary soil, which is the forbidden question here. Not what is this white stuff, but why were we taught to fear one of the engines that makes a backyard live? For a very long time, fungi arrived in the human imagination as omens. Romans blamed crop rusts on divine anger and held a festival called Robigalia to appease a god of blight. In parts of Europe, strange growth on food, timber, or fields was read as curse, punishment, or corruption. Rings became portals. Sudden mushrooms were lightning marks. Mold on crops could be witchcraft. A foul-looking fungus in the yard might mean that something unseen had chosen your home. We are being fair to our ancestors. You can understand the instinct. Fungi emerge from nowhere. They erase the boundaries between life and death. They bloom after rain, disappear by noon, turn from underground like a thought you did not invite. Their kingdom works in concealment. Their most important parts are usually hidden. That alone is enough to make a species like ours suspicious. But suspicion is not understanding, and in this case, it may have hidden something astonishing in plain sight. For more than 2 centuries, naturalists, foresters, and soil biologists kept recording the same quiet fact. Where leaves fall and stay damp, where wood softens, where mulch darkens into crumbly earth, fungal threads appear first, not last. First, it gradually learned that the white web under leaves is often mycelium, the feeding body of a fungus built from branching hyphae that explore litter, bark, roots, and soil particles. Threads release enzymes outside their bodies, digest complex material in place, and then absorb the smaller molecules back in. Cellulose, hemicellulose, in many cases even lignin, and structural polymer that gives wood much of its toughness. In other words, what looks like contamination is often a recycler already at work. The public heard the warning. Scientists heard the process. That gap has lasted a very long time. And to be honest, even experts have had to approach this world with humility. Fungi are hard to study because most of their lives unfold underground, inside wood, or in the thin wet film between soil particles. A mushroom is only the reproductive structure, not the main body. The real organism may spread invisibly for meters, years, sometimes far longer than the eye would ever guess. Researchers have known for decades that fungi were central to decomposition and plant partnerships. But many details of how they build networks, route nutrients, regulate traffic, respond to local conditions have only become clearer with newer imaging, genetic tools, and long-running experiments. So, if the white web unsettles you, that does not mean you are foolish. It means you are meeting an ancient system at exactly the point where human intuition begins to fail. And now the layers begin. First, the white web is usually a sign that the ground is processing death correctly. Not simply vanish, they have to be chemically dismantled. The dry brown skin of autumn is made of compounds that most animals cannot efficiently break down on their own. Saprotrophic fungi can. They move into fallen leaves, bark, and mulch, secrete enzymes, and unlock nutrients that would otherwise remain trapped. Carbon, nitrogen, phosphorus, oxygen-bearing compounds, all of it has to be returned to circulation somehow. Together with bacteria, fungi are among the great decomposers that keep this cycle moving. Without them, forest litter would accumulate, would stall, and the thin living skin we call soil would lose much of its fertility. So, when you lift a mat of leaves and find white filaments binding them together, you may be looking at a system that is not killing your garden, but digesting yesterday so tomorrow can root in it. That alone would be remarkable. But that is only the outer page, because the second layer is this. All white fungal growth under leaves is doing the same job. Some fungi are saprotrophs, specialists in dead material. Others are pathogens, and others form mutualisms with plants, mycorrhizae, literally fungus root partnerships. More than 80% of land plants, over 250,000 species, are thought to form some kind of mycorrhizal association. That means the alliance between plants and fungi is not a fringe exception in nature. It is one of the standard operating systems of terrestrial life. A plant makes sugars and fats through photosynthesis. Trades reach. Its hyphae are finer than roots, able to enter tiny pores in the soil and extend the plant's effective foraging range for water, phosphorus, nitrogen, and micronutrients. In drought, this matters. Soil, this matters. In crowded ground where roots compete, this matters even more. The white web under leaves may not itself be attached to a living root at the moment you see it, but it belongs to a kingdom whose networks routinely widen the sensory and nutritional horizon of plants. And then there is the third layer. Fungi do not merely break things down or ferry minerals around. Build the physical fabric of soil. Hyphae weave between particles, roots, and tiny crevices in a way that improves aggregation. The formation of small stable clusters in the soil matrix. Aggregation means better pore structure. Better pore structure means more reliable movement of air and water, less erosion, habitat for the countless other organisms that make a healthy soil food web possible. That is the strange inversion. The thing many people read as a sign of dirtiness is often one of the reasons soil has structure at all. But here is what many people missed. The fourth layer is scale. Networks are usually microscopic in their details and enormous in their consequences. Most are too small to notice unless conditions bring them to the surface in a pale bloom. Fungal organisms become gigantic. In Oregon's Malheur National Forest, one Armillaria ostoyae individual has been estimated to cover about 2,385 acres, roughly 3.7 square miles, or almost 10 square kilometers, with an estimated age in the thousands of years. It spreads slowly, in some reports less than a few feet per year, but over deep time slowness becomes immensity. Perception. So when you see a white web under a layer of maple leaves, you are looking at a life form built on a different mathematics of presence, not flashy persisted. Quiet things become vast when no one interrupts them. Perception. And then there is the fifth layer, the one that has made fungal research feel almost philosophical. In 2025, researchers using long-term robotic microscopy described underground fungal transport in extraordinary detail. Showing that nutrient-rich fluids can move in different directions within the same mycorrhizal network, and that the network adjusts where demand is greatest, especially near plant roots. Was not evidence of a magical hive mind. It was something better, a decentralized living system solving transport problems, locally, elegantly, continuously, without any visible conductor. Because it changes the emotional meaning of the white web. What looks to us like aimless spread may be responsive architecture. A network sensing gradients, opportunities, congestion, contact, body that computes through growth. And once you allow that thought in, the backyard becomes harder to dismiss. Now for the sixth layer. The conversation around fungal networks has sometimes become inflated, as if every root and every hypha were part of a benevolent internet of the woods, transmitting wisdom in ways too romantic to measure. The truth is more disciplined than that. Scientists do have evidence that some plants can exchange resources and, under certain experimental conditions, warning signals through mycorrhizal connections. Q summarizes greenhouse work in which tomato plants infected with early blight signaled neighbors that then boosted defensive enzymes. Other plants, like certain orchids, so completely on fungal partners during germination that without the right fungus, they do not really begin. That is not myth. But neither is it permission to become careless with the science. Fungi are not saints. They're all helpers. Some rot crops, some parasitize roots, some kill trees slowly, some white growths under leaves are tied to conditions that are too wet for the plant above them. Identification still matters. Still matters. If living stems are collapsing, roots smell sour, or leaves are covered in lesions, the story changes, which brings us to the seventh layer, the one closest to home. In gardens, web under mulch or leaf litter often appears exactly where life is being turned back into possibility. University extension gardeners describe it as a common sign of biologically active beds. It can hold moisture, treat for microbes, and help transform chips, straw, and leaves into dark humus. In practical terms, this means the frightening-looking material under your roses, tomatoes, or hydrangeas may be part of the reason the bed improves year by year, not despite decay through it. And if that feels like a reversal, it should, as much of nature's intelligence is hidden inside processes we were taught to mistake for mess. I'll be honest, this one shook me. Not because the facts were grotesque, but because they were gentle and absolute at the same time. I had to sit with the idea that a white film I once would have scraped away without a second thought might, in many cases, be the visible handwriting of renewal. At under the leaves, in the smell of damp earth and slow rot, there is a choreography older than forests as we know them. Plant carbon moving into fungal tissue, hyphae crossing particles finer than dust, bed matter dissolving into future roots. It is one thing to learn that fungi are useful. It is another to realize how much of the living world is quietly held together by things we barely tolerate seeing. Perception. And once you feel that, even slightly, the garden stops looking decorated. It starts looking busy. So, let's return to the question. Why does a white web under leaves make us panic? Because some ancient part of us still associates hidden growth with spoilage and threat. Partly because fungi refuse the categories we like. They are neither plant nor animal. They appear where things are ending, but they are also responsible for beginnings. They can nourish, they can infect, they can preserve a forest's nutrient economy, or hollow out a trunk from within. The same kingdom that gave us penicillin also gives us blight. Architecture that helps roots reach farther can, in other species and circumstances, become an instrument of disease. So the original question is not completely answered. Maybe it never will be. What disturbs us is not just the white web itself. It is the reminder that life does its most important work where we do not usually look, under the leaves, under the bark, under the story we inherited. If you've ever found this white web in your own yard, I want to hear your theory. Drop it below. The strangest one gets pinned. And the next question we'll ask is even older. Perception. The answer was hiding in your grandmother's garden the whole time.